All right, hi everyone. Today we are going to talk about a few more rules with exponents. We're going to learn about the product, the power, and the quotient rules. So it's just a few more properties about how exponents work together and how we can simplify them. So let's start with the product rule. So the word product means multiplication in math. So this is going to involve multiplying exponents together. So something like this down here, x to the a times x to the b, and we're going to learn what happens with these exponents. So before I tell you what the rule is, I'm actually just going to show you in this little space here how this works. So let's take, for example, x to the third power, and we're going to multiply that by x to the second power. So a really easy way to understand this would be to take each of these expressions and expand them out. So for example, x to the third is the same thing as x times x times x, right? We learned the other day that's how exponents work. And x to the second is x times x. Now if I multiply all of this together and just write it as one expression, we have 5 x's that are being multiplied together. So we can rewrite that as x to the 5th power. So that's the answer for this. Now notice, if you look at the exponents, they really just got added together, right? 3 plus 2 is 5. So that's how you multiply exponents. You don't actually multiply them, you just add the exponents together. So this works as long as these have the same base. So it's got to be the same letter or the same number, and then you could just add the exponents. So that's what the product rule says. It says when you multiply exponents with the same base, you just add the exponents. So this would be x to the a plus b. Okay, so now that we know how the rule works, let's go ahead and use it in those few examples down below. So here's our examples: 3 to the second power times 3 to the 6th power. So because the 3 has the same base, right, we can just add these exponents. So this would equal 3 to the 8th power, and you could even type that into your calculator if you'd like, and you can evaluate what that would be. We learned how to do that the other day. You just hit 3 and then the caret button, and then you can do the 8th power. So that should equal 6,561. Okay, moving along, we got the next one, y to the 7th times y to the 4th. Again, you would just add the exponents, so that would be y to the 11th power. And then down here we have one with multiple letters. It works the same way, you just make sure you put the letters together that go together. So if you look at the C's, 5 plus 2 is 7, so that would be c to the 7th. And then for the D, don't forget that this one over here actually does have a power. It's to the power of 1. You just can't see it there. So it would be 3 plus 1, which is 4. So this would be D to the 4th. Okay, so that is how product rule works. So when you multiply exponents, you just add them together. Now we're going to talk about something similar, but it is a little different. This one is called the power rule. So this is when you have a power that's being raised to another power. So there's an example here, but before we talk about how the rule works again, I'm just going to show you an example of what's happening right here in this space. So let's take, for example, x squared. I'm going to put it in parentheses, and we're going to raise that to the 3rd power. So this is x squared, but then that whole thing is being raised to another power. So again, I'm just going to expand this out so that we can make this make a little bit more sense. So x squared is the same thing as x times x, right? But if I want to take this whole thing to the 3rd power, that means I want to multiply all of this by itself 3 times. So I'm going to write that out. We would have x times x times x times x times x times x, right? That's what that would mean. So if you look at all the x's that we have left over here, we have 6 altogether. So if I want to rewrite this as one single expression, it would be x to the 6th power. And if you compare this exponent to the original exponents, 2 times 3 is 6. So that's how the power rule works. So instead of adding the exponents, you're multiplying the exponents. Okay, so we'll go ahead and fill that in up here. So when you raise a power to another power, you just multiply the exponents. So in this example, x to the a to the b power would be x to the a times b. Okay, so let's look at those few examples at the bottom here. So again, we're just taking the exponents and we're just multiplying them together. So 4 to the 6th to the third power, you would just multiply the 6 by the 3. That would be 4 to the 18th power. Now, if you want to put that in your calculators, you can. This is going to be a very, very, very large number, though. So I'm just going to leave it like this. I'm not going to actually calculate that out. Okay, next one. We have two different letters in the parentheses. So you're going to take each of these and you're just going to multiply them by that 4 on the outside. So this becomes x to the 8th power. And then the y would be to the 20th power because 5 times 4 is 20. Okay, if you have a fraction, you would do the same thing. You're going to take this exponent on the outside, and it's just going to get multiplied to both of these exponents on the inside. So that would be x to the 60th power over y to the 30th power. Okay, so now we're going to look at a few more examples of both of these rules, except we're going to look at some that have coefficients. And if you remember what this word means, a coefficient is a number that's in front of a variable. So if you look at this example right here, we have a 4 in front of the x squared, and over here we have a 3 in front of this x to the 5th. So we're going to talk about what to do when that happens. So let's start with the product rule. So with the product rule, and remember, this is the one that said that we have to add the exponents, right? Now, you're not going to add the coefficients. That's not how that would work. So, for example, let's just pretend for a second that this x squared wasn't here and that this x to the 5th wasn't here, right? This just says 4 times 3. Well, we know that 4 times 3 is 12, right? So if you see coefficients like this, you're just going to multiply those just like you normally would. So we're not going to add them, we're going to multiply them together, okay? Now, with the exponents, x to the 2nd power times x to the 5th power, now we can just add those together like we did on the other page. So that would be 7, so this would be x to the 7th. So the whole answer would be 12 x to the 7th. Okay, so you're just going to multiply the coefficients, but add the exponents. Okay, let's take a look at the next one. Same thing here. So we have these coefficients, right? 5, -4. We're going to multiply those together. That's -20. And then for the exponents, we're just going to add them. So x to the 3rd, x squared. If I add those, that's 5, so x to the 5th. And then we have y to the 3rd. And then this one, just think of this as y to the 1st power, right? So 3 plus 1 is 4. So there we go. That's our final answer for that one. Okay, this last example, it looks like we're multiplying 3 pieces together, right? Pretend there's little dots in between these. So it means this times this times this. Now let's start with the coefficients. So now remember, if you don't see a coefficient, there is one, you just can't see it. It's a 1, right? So just treat this like a 1. Treat this negative sign here. I want you to think of that as a -1, okay? So we're going to multiply all of these together. 1 times 8 times -1. That would just equal -8. And then now let's take care of the letters. So we have m right here, that's m to the 1st power, right? M to the 1st, m to the squared, and then another m to the 1st here. So we have 1 plus 2 plus 1, that's 4. So m to the 4th power. And then for the n's, we have 9, 10, 11. So n to the 11th. Okay, there we go. Now for power rule, it's kind of the same thing. So if you see a coefficient, you are just going to do to that coefficient whatever you normally would do. So for example, I'm going to zoom in on this one. Let's pretend that these letters aren't here for a second. Okay, let's just pretend it said 2 and then to the 5th power, right? If this is what it looked like, we would just do 2 to the 5th power. We wouldn't do 2 times 5, right? We wouldn't say that that's 10. We would do 2 times itself 5 times. So you're basically just going to take that coefficient and you're going to raise that coefficient to the power that's on the outside. Here's another way to think of this that might make it a little easier to remember. Anything inside of these parentheses that doesn't have an exponent on it, I want you to put a 1 just right in the little exponent. So there's going to be a 1 on the D. There's also going to be a 1 on the 2. And now we just take this power on the outside here and we multiply it to all of those powers. So this is going to turn into 2 to the 5th power, c to the 15th power, and d to the 5th power. Now this 2 to the 5th, you can actually calculate that out. You can type that in your calculator if you want to, but let's go ahead and see what that would be. So if you type that in, that's going to be 32. So we can say 32, c to the 15th, d to the 5th. Okay, so with power rule, that's how it works. You take the coefficient, the big number here, and you just like raise that to the power on the outside, and then you just multiply all these exponents. So I think it's easy if you just put the little ones here, and then you're almost like distributing this exponent to all of the other ones. So same thing with fractions. With a fraction, pretend there is a 1 on that a, right? And then think of this -10, think of that as like a negative number, right? So it's -10 to the 1st power. So here's what we would have, 3 times 1, 3 times 1 here. So this would turn into a to the 3rd over -10 to the 3rd. Now you can actually simplify that -10 to the 3rd. You can just raise that to the 3rd power. So this would be a to the 3rd over -1000. Okay, same thing with the next one. So I'm going to put a 1 on anything that doesn't have an exponent. So there's going to be a 1 on the 3 and then a 1 on the 2. And then we just take this exponent out here and we multiply it to all of those. So this would be 3 to the 4th, m to the 20th. And then on the bottom, we would have 2 to the 4th. Now, I do want you to simplify as much as you can. So this 3 to the 4th and this 2 to the 4th, you're going to calculate those out. You can type them into your calculators if you want to. So that would give us 81 on the top. We still have our m to the 20th. And then on the bottom, 2 to the 4th is 16. Now, another thing that you should always get in the habit of doing, 81 over 16, you want to ask yourself if this fraction can be reduced. Now, in this case, it can't. 81 over 16 does not reduce. But sometimes this fraction can be reduced. So if it can be reduced, make sure you always reduce that down. But in this case, we're just going to leave it the way that it is. Okay, now let's put this all together. We're going to do some examples that have multiple steps, okay? So now my directions got cut off a little bit here, but I can still see the problem enough for us to do this. So let's take a look at this one. If you have parentheses, you're going to take care of those first. So we're going to take this power on the outside here, and we're going to multiply it to both of these. So this would be x to the 9th times y to the 9th. And then we're going to drop this piece down. So times xy squared. Okay, so what we just did was the power rule. This is the one where you take the power on the outside and you multiply it to the ones on the inside. Now, what we're left with is just the product rule, right? There's no more parentheses. There's no more exponents on the outside. So now this is the one where you just add the exponents. So take a look at the x's. We have 9 and 1 right there. So that would be x to the 10th. And then for the y's, we're going to have 11. Y to the 11th. And that's the final answer for that one. Okay, next one, same thing here. We're just going to take it one little piece at a time. Now we have 2 sets of parentheses, so we're going to have to take care of both of those. Also, see this negative right here? Remember, that's actually like a -1. I want you to treat that like a -1. So we're going to have this exponent on the outside. That's going to get multiplied to all the exponents on the inside. So I see a 7 right here. Remember, there's also a 1 on the A, and then there's also a 1 on this -1 right here. So let's take care of these exponents. So this would be -1 squared, A squared, B to the 14th. So all I did was I took this 2 and I just multiplied it to all these. Okay, let's simplify this a little bit more. -1 squared is the same thing as just 1. So, and again, we don't really need the 1 because it's just a coefficient. So anytime your coefficient is the number 1, you don't actually need to write it. So I'm just going to drop these 2 down here. So we have A squared, B to the 14th. Okay, that one is ready to go. Now let's take care of this other one. So same thing here. I'm going to put a 1 on the B. I'm going to put a 1 on the 12. And then we're going to multiply this exponent to all of those. So this is 12 squared, A to the 6th, B to the 2nd. And then we're going to simplify that 12 squared. 12 squared is 144. So I'm going to drop this down. All right, and then this dot right here. So remember, we're supposed to take these two and multiply those together. So now this is the product rule. This is where we're going to look at the exponents that match, and we're going to add them together. So that 144, that's just going to come down in front. And then for the a's, we have 8 of those, so a to the 8th. And then for the b's, we have 14 plus 2, so b to the 16th. There we go. Okay, let's take a look at this last example over here. Same thing, we're gonna just do it in little pieces. So let's start with that first set of parentheses. So this is going to be power rule. We're gonna put little ones on our numbers here that don't have exponents. And then we're just gonna multiply that 3 to all of those. So it would be 6 to the 3rd, a to the 6th, b to the 3rd. And then I would always simplify these numbers here, right? So 6 to the 3rd, you're just going to go ahead and multiply that out or type it into your calculator. That turns into 216. Okay, so here's what we have for that first piece. Now the second piece, same thing here. You're going to take that exponent on the outside. Now on the inside, notice that nothing has an exponent on it, right? That means they're all ones. So everything in here has a little 1 on it. So now that we have a 2 on the outside, they're all going to turn into 2's. So this would be 1 squared over 3 squared, a squared, b squared, c squared. And then we're going to simplify that fraction, right? 1 squared is 1, 3 squared is 9. So this simplifies into 1/9, a squared, b squared, c squared. And then finally, we're going to clean this up and write our final answer. So for the coefficients, you are just going to multiply those. 216 times 1/9. You can type that in your calculator if you want. It's also the same thing as dividing by 9, right? If you multiply by 1/9, you're really just dividing by 9. So it's kind of like 216 divided by 9. That equals 24. And then now for the exponents, you just add them together. So a to the 6th and then a to the 2nd, that would be a to the 8th. B to the 3rd plus b to the 2nd is b to the 5th. And then the c just comes down. We don't have anything to add with that one. So there we go. That's our final answer. Okay, so now I want to remind you about negative exponents. This is what we talked about the other day, yesterday. So sometimes you're going to have negative exponents in these, and if you do, you have to rewrite those as positive exponents, just like we were doing yesterday. So let's take a look at our first example. So if I were to treat this the way that we've been treating it, right? We have a power on the outside and a power on the inside. This is when we multiply those exponents together. So 4 times -3 is -12. So this would be z to the -12th power. But yesterday we talked about how to handle negative powers. So if you see a negative exponent, we're going to rewrite that. This is the same thing as 1 over z to the +12th power, right? That's how negative powers work. They just flip to the other side of the fraction. So this was an originally, like pretend there's a 1 on the bottom here, right? That negative exponent is going to come down to the bottom, and all we're going to be left with up top is the number 1. So this is the final answer for that one. So basically you just treat everything like normal, except if you see negatives in your answer, you got to simplify that a little bit further to get rid of those negatives. So let's take a look at this one over here. This one has a few different steps. We have a power on the outside here. That's going to apply to everything on the inside. So remember, there's little 1s on all of these, right? And then treat this negative. I want you to treat that like a -1. So we're going to have -1 squared, x squared, y squared. Now that -1 squared, that's just going to disappear because it's equal to +1, and we really don't need to write +1, right? So we're just going to get rid of that. And then over here, I'm just going to drop this down for a second. So we have 8, x to the -7, y to the -2. Okay, so now we've taken care of our parentheses. This is where we're going to apply the product rule, which means we're just going to add these exponents. So the 8 is just going to come down in front. And then for the x's, we have 2 plus -7. That's -5. And then 2 plus -2, that's technically 0, right? Y to the 0. Now, we learned yesterday that y to the 0, or really anything to the power of 0, this is always going to equal 1, +1. So we really don't need to write this either because it's the same thing as 1, and 8 times 1 is just 8, right? So we do not need to write y to the 0. So the only thing that's going to happen here is that this negative exponent is going to have to move to the bottom of the fraction. The 8's going to stay where it is, because remember, the 8 doesn't have a negative exponent. It has a positive exponent of 1. But that negative exponent has to move down. So this whole final answer here would be 8 on the top of the fraction, and then x to the 5th on the bottom of the fraction. So that's the best way to simplify something like that. Okay, let's go ahead and move on to the next page. Okay, so now we're going to talk about the third and final rule today, which is the quotient rule. So the word quotient, this means division. So this is going to involve dividing exponents. So let's look at what happens when you divide exponents with the same base. So just like the other rules, I'm going to show you over here how this works, and then we'll fill in that box together. So let's take something like x to the 6th power, and I want to divide that by x to the 2nd power, okay? So I'm going to expand this out so we can see what's happening here. So this would be x times x times x times x times x times x. So I just wrote 6 x's that are being multiplied together. And then on the bottom of the fraction, we would just have 2 of them, right? X times x. So here's what I'm going to do in order to think about how this division would work. When you divide something by itself, so x divided by x, that just equals 1, right? X divided by x, that's just positive 1. That's what happens when you divide anything by itself. 5 divided by 5 equals 1. 10 divided by 10 equals 1, right? So this right here just equals 1, which means I can cancel this out because we really don't need to put 1, right? 1 as a coefficient doesn't really do anything. So we can cancel a set of those out, and then we can cancel another set out here. This also equals 1. So if I cancel those out, look at what we have left. We have 4 x's up top. That is the same thing as x to the 4th power. So if you notice what happened with the exponents here, 6 minus 2 is 4. So when you divide exponents, you really just subtract them. It's kind of like the opposite of the product rule, and that would make sense, right? Because multiplication and division, those are just opposites. So instead of adding them, we can just subtract them. So dividing exponents with the same base, you just subtract the exponents. So this would be x to the a minus b. Okay, so let's just take a look at these few examples here. So that first one, we have 4 to the 6th divided by 4 to the 3rd. So because these have the same base, we can just subtract the exponents. 6 minus 3 is 3. So this is the same thing as 4 to the 3rd power. And if you wanted to go a step further and evaluate that out, you could. You could just type that into your calculator if you want. That is 64. Okay, the next one, same thing here. We have x is the same base, right? So 4 minus 3 is 1. So this is x to the 1, which is really the same thing as just x. If you have an exponent of 1, you don't have to actually write it down. All right, last example here. So we have multiple letters. You're just going to subtract the ones that go together. So 7 minus 2, that's 5. So a would be to the 5th power. 3 minus 1, that's 2. And then 5 minus 1 is 4. So that whole answer would look like this. A to the 5th, b squared, c to the 4th. And then when we have coefficients, just like the other examples, if you have numbers in front of your variables, you're just going to divide those just like we normally would. Okay, you're not going to actually subtract them. So over here, like for example, if these were not there, we would just normally divide these, right? 6 divided by 2 is 3. So we're going to write this part as 3. Now with the exponents, you just subtract. 4 minus 3 is 1, so that would be just 3x. Same thing over here for this one. We have negative 15 divided by negative 3, that's positive 5. And then I'm just going to subtract all these exponents. 6 minus 5 is 1, so I'm just going to put x. 5 minus 3 is 2, so y would be to the 2nd power. And then there's nothing to subtract from the z, so we're just going to bring the z down right next to it. So there we go. That's the answer to that one. Okay, if you end up with something like this, 36 and 54. If you tried to divide those, you would get a decimal. So instead of dividing, I'm just going to reduce this fraction. I'm going to try to find numbers that go into both of these numbers. Now, if you're really good with your factors, that might come easy to you. 36 and 54, a number that goes into both of these is 9. So if you divide them both by 9, this whole fraction would reduce. So 36 divided by 9 is 4. And then 54 divided by 9 is 6. And that also reduces, again, that reduces down to 2/3. So when you do these, just try to think of a number that goes into both of these. You can even start with a number as small as 2 if you want. Just divide them by 2 and then just keep dividing them until it reduces all the way down. This is also something that you can do in your calculators, and I can show you that when I come back if you'd like. But yeah, this fraction reduces to 2/3, so I'm going to write it as 2/3. And then for the exponents, we're just going to subtract. 9 minus 3 is 6, so that would be m to the 6th power. And then 5 minus 2 is 3, so n to the 3. There we go. Okay, the last page here, we're just going to look at some more examples that have negatives, and then we'll do some multiple step examples. So remember, negative exponents can always be a thing. So if you see them, just make sure you are rewriting them as positive exponents. So in this first example here, this is a division, right? Y to the 6th divided by y to the 7th. This is when you just subtract. Now the order does matter. You do have to subtract the bottom one from the first one. So it's always the top minus the bottom. So 6 minus 7 is -1. So this is technically y to the -1st power. But because that's a negative power, we're going to rewrite this. So this would be the same thing as 1 over y to the +1 power. But remember, we don't really need to put that 1 there. So we're just going to call this 1 over y. So that's the answer to that one. All right, same thing for the next one. We're going to subtract these exponents. 5 minus 7 is a -2. And then 3 minus 3, that's 0, right? But remember, d to the 0 is just 1. So anytime this happens, these just kind of cancel each other out, and we don't even have to write it. So all that we have left is this right here, c to the -2. But because that's negative, we're going to rewrite this. So it's going to be 1 over c to the +2. Okay, and then the final example over here, now we have some coefficients. So we're going to divide those, right? -10 divided by 2, that's -5. And then we're going to subtract. So for the x's, we have 3 minus 6. That's -3. And then we have, be careful with this one is 2 minus -5. So be very careful with that. 2 minus -5. That's going to turn into addition, right? This is like 2 plus 5. So that's 7. So the y would be to the 7th power. Now, we do need to rewrite this a little bit. The only negative power that I see is the one on the x. So that one's going to come to the bottom of the fraction, x to the 3rd. And then your -5 and your y to the 7th, that's going to stay up top. So there we go. That's the final answer for that one. Okay, the last few examples we have here are just some multi-step examples. These just involve a lot of simplifying, and these can be kind of tricky. So just take it one piece at a time. I would completely simplify the numerator and the denominator first, and then I would just use the quotient rule to do everything else. So let's take a look at that first one. So let's start with the numerator because I see some parentheses up there, right? So if we take care of those parentheses, this is when we take this exponent and we just multiply it to all of the exponents. Remember, there's a 1 on this 2 right here. So the top of this fraction is going to turn into 2 to the 3rd, a to the 6th, b to the 12th. And then on the bottom, we have all of this still. Okay, the next thing I would do is I would go ahead and simplify that 2 to the 3rd. I'm actually going to take care of that right now. 2 to the 3rd is 8, right? 2 times 2 times 2. So instead of 2 to the 3rd, I'm going to write this as 8, and that's going to make this easier to simplify. Okay, now we can just do the quotient rule. So 8 divided by 4, that's just 2, right? And then we can take our exponents and subtract them. 6 minus 3 is 3. 12 minus 7 is 5, so that would be b to the 5th. There we go. 2a to the third and b to the fifth. Okay, next one, same exact process here. We're going to simplify the top of the fraction. So I'm going to take this exponent outside, multiply it to these. So that would be 3 squared and then x to the 10th, but 3 squared is 9. So we're going to write it as 9x to the 10th over 27x to the third. Okay, so let's take this fraction right here, 9 over 27. That reduces to 1/3, and then 10 minus 3 is 7, so that would be x to the 7th. There we go. 1/3 x to the 7th. Another way to write that, you can also just put the x to the 7th up top, and then the 3 on the bottom. That's the same thing. Okay, this next one here, we got to simplify both the numerator and the denominator. So I'm going to take this 3 on the outside here and apply it to both of these. So we have -6 to the third power, and then x to the 6th power. And this would be over, let's see, 3 to the 2nd power, and then x to the -8 power. Okay, before we do anything else, I want to evaluate both of these numbers right here. So you can use your calculators for those if you need to. -6 to the third, that equals -216. You can just type that right into your calculators if you want. And then x to the 6 would be right next to it. Now we know 3 squared is 9, so on the bottom we have 9x to the -8. Now I would simplify this if possible, so see if 9 goes into 216. So just do -216 divided by 9, and that does divide nicely. That equals -24. And then your exponents, you're supposed to subtract these. So it's 6 minus -8. That's going to turn into addition. 6 plus 8 is 14. So it would be x to the 14th power. And there we go. That's how we would leave our answer. I don't see any negative exponents, so we don't have to rewrite them. Remember, negative numbers are fine. You just can't have negative exponents. Okay, last example here. We have to first simplify this exponent on the outside. So we're going to multiply that to all of the exponents on the inside, both top and bottom. So a lot of multiplying here. So we have 3 to the 4th, x to the 20th, y to the 12th, over x to the 12th, y to the 24th. Okay, so now let's calculate that 3 to the 4th, just so we can simplify that down a little bit. So 3 to the 4th, you can type it into your calculator if you want. That equals 81. So I'm going to put 81, and then I'm just going to bring all this down. Okay, now we're supposed to use the quotient rule and subtract the exponents. So 20 minus 12, so we would still have our 81. 20 minus 12 is 8, so x to the 8th. And then 12 minus 24, that's negative, so that's going to be -12. And then finally, you have to deal with the negative power. So we have to move that one down. So your final answer would be 81x to the 8th on top, and then y to the 12th on the bottom. Okay, that is it for notes. You can get your homework and start working on that.